So for number 1, we want to determine the quadrant in which the angle lies. So our quadrants start in the upper right-hand corner. This would be quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We're a little bit more familiar with degrees. So the whole, all the way around would be 360 degrees. So if we start here at 0, each one's going to be 90. So 0 to 90 is quadrant 1, 90 to 180 is quadrant 2, 180 to 270 is quadrant 3, and then 270 to 360 is quadrant 4. So it's a little bit easier for us to see where degrees fall, which quadrant degrees would fall into. So it might help us if something's given to us in radians, let's convert it to degrees to figure out where this would go. How would I convert to degrees? Awesome, multiply by 180 over pi. So pi's cancel. 12 goes into 180. (15 times). So we have negative 5 times 15 would be negative 75. So which quadrant would negative 75 degrees fall into? Quadrant 4, awesome. Negative, we start by going down, so it'd be in quadrant 4. Let's look at number 3. So 3 is a super large angle. How would we find what quadrant this falls into? For 3. We can subtract 360. So remember, you can subtract or add 360 to find a coterminal angle to see where this would fall in between 0 and 360. So I would take 1,265 and subtract 360. It's still bigger than 360, so let's subtract 360 again. Still bigger than 360, so let's subtract 360 again. Finally, we got something that is in between 0 and 360. So I had to subtract 360 3 times to get 185 degrees. What quadrant does 185 degrees fall into? Bless you. Quadrant 3, awesome. So quadrant 3 would be our answer. All right, let's take a look at number 5. We want to determine 2 coterminal angles for the following. So to find coterminal angles, we can add or subtract 360 if it was given to us in degrees, or add or subtract what if it was given in radians? 2 pi, perfect. So if the question is given to you in radians, make sure your coterminal angles are in radians as well. It's got to be the same unit. So for number 5, how would we find a coterminal angle? Plus 2 pi. So when we're adding with fractions, we need a common denominator. So I can make this 2 pi over 1, but we got to multiply the top and the bottom by 6. So 12 pi over 6. 7 pi plus 12 pi is 19 pi over 6. So this would be an example of a coterminal angle. This is a positive coterminal angle. How could we find another coterminal angle? Awesome. We can take 7 pi over 6 and subtract 2 pi. So again, here we need a common denominator, so I can multiply the top and the bottom by 6. What's 7 pi minus 12 pi? Negative 5 pi over 6. So we have a positive and a negative coterminal angle. So remember, you can add or subtract 2 pi as many times as you want. You can add 2 pi 5 times, and that would give you a coterminal angle. There's an infinite amount of correct answers here. So you just add or subtract 2 pi. What about if we were given in degrees? What would we do to find a coterminal angle? So we can add 360 to find a positive 1 here. So 118 plus 360 would be 478 degrees. How do we find a negative coterminal angle? subtract 360. So 118 minus 360 would be negative 242 degrees. So there is our positive and negative coterminal angle. When you're writing degrees, make sure you put the little degrees symbol. If you don't put the degrees symbol, you'll lose points. So don't forget that. What about for 18? For 8, how would I find a positive coterminal angle? Add 360. So if we add it just once for now, we've got negative 397 plus 360. That gives us negative 37. Is this a positive coterminal angle? No, but it is a coterminal angle. It's just negative because it's got a negative out front. It could ask for a positive and a negative.
So it just asks for coterminal.
You can give me any one of the coterminals. But if it asks for a positive one, what would we need to do? Add another 360. So I'd take negative 37 and add another 360 to it. So remember, you can add or subtract more than once. So we get positive 323 degrees. You could just take the original, so negative 397, and subtract 360. This would be a perfect answer for a negative coterminal angle. But you could also find one by subtracting. So another negative coterminal angle would be negative 757. So these are both negative coterminal angles. All right, let's look at number 9. So we're converting. So how would we convert from degrees to radians? Multiply by pi over 180. Perfect. So I'm going to simplify before I multiply. So 5 goes into both 65 and 180. So it goes into 65 13 times, and 5 goes into 180 36 times. So negative 13 pi over 36. Can we simplify this anymore? Nope. So this would be our radians. What about for 11 when we're converting from radians to degrees? Multiply by 180 over pi. So pi's cancel. 12 goes into 180. 15 times. So we have 15 times negative 7 would be negative 105. Negative 105 what? Degrees. All right, for 13, we want to find the complement and supplement if possible. How would we find complementary angles? Awesome. So they add up to 90 for complementary, but we always do 90 minus the angle. But what if it was given in radians? You could convert it, but that would be a lot of work. What else could we do? What's the equivalent to 90, but in radians? Pi over 2. So we do pi over 2 minus the angle. What about for the supplement? What do 2 supplementary angles add up to? 180. So we do 180 minus the angle. And then what if it was in radians? Pi minus the angle. So complementary add up to 90 or pi over 2. And then supplementary add up to 180 or pi. So for number 13, how would we find the complement? There is none. Yeah. So we would do 90 minus 159. And we get a negative. Is it possible to have a negative complementary angle? No. Can't be negative. So we would say no complement, or you could say does not exist, NA, none, whatever you want to put. There is none. So complement and supplement have to be positive. So it has to be 2 positive angles that add up to 90, or 2 positive angles that add up to 180. How would we find the supplementary angle? 180 minus the angle, so 159. What's 180 minus 159? (21) what? Degrees. Perfect. So that would be our supplementary angle. Do you want to practice the radians? All right, let's do it. So let's start with our complement. What do our complementary angles add up to in radians? Pi over 2. Awesome. So we're going to do pi over 2 minus the angle, 3 pi over 4. We need a common denominator, so I can multiply the top and the bottom here by 2. We get 2 pi over 4. What's 2 pi minus 3 pi? Negative pi over 4. Can we have a negative complementary angle? No. So what would our answer here be? None. No, does not exist. No complement. Let's find our supplementary angle. What do 2 supplementary angles add up to in radians? Pi. So we're going to do pi minus 3 pi over 4. So pi I can change to 4 pi over 4 to give us a common denominator. 4 pi minus 3 pi is? Pi. Awesome. Pi over 4. So that would be our supplementary angle. So for number 15, it says find the length of the arc of the radius r intercepted by central angle theta. Leave your answer in terms of pi. What is our arc length formula? S is equal to r times theta. And what does theta have to be in? Radians. So theta has to be in radians when you're using this formula. So for 15, it's asking us for S, so that's what we're trying to find. What's R? 7. And what is theta? 240, but what do we have to do to 240? Convert it, because it has to be in radians. So 240 times what to convert? Pi over 180. 10 goes into 240 and 180. So we have 24 pi over 18. What goes into both 24 and 18? 6 goes into 24 4 times, and 6 goes into 18 3 times. So 4 pi over 3. So our theta has to be in radians. It's 4 pi over 3. So S is equal to R, which is 7, times theta, which is 4 pi over 3. When we multiply these together, it says leave your answer in terms of pi. So you don't want to put it in the calculator. We're just going to multiply straight across. Make it 7 over 1. Multiply the tops together, the bottoms together. Yeah. So leave your answer in terms of pi. What's 7 times 4? 28 pi over 3. Can we simplify? No. So that would be our answer. Awesome. So this one, you're not putting it in the calculator. It says leave your answer in terms of pi. Just leave pi like that. Let's look at 17. We want to determine the exact values of the 6 trig functions. So on the quiz, it's not going to give you like the 6 trig functions. It might ask for just one. It could ask for 3 of them or 4 of them. So make sure you know which ones are reciprocals of which. We'll start with our 3 main trig functions. So sine, cosine, and tangent. What's the reciprocal of sine? Cosecant. Perfect. CSC. What's the reciprocal of cosine? Secant. SEC. And the reciprocal of tangent? Cotangent. So sine corresponds to what? The y. Awesome. So this is our x and our y. So our y is going to be negative 7 over 25. Cosine corresponds to what? X. So our x is negative 24 over 25. Tangent, we look at what? Y over x. So we got to do a little bit more work here. Our y is negative 7 over 25 over x, which is negative 24 over 25. So we're going to, what do we do when we have a fraction and a fraction? Keep, change, flip. Keep the top, change to multiplication, flip the denominator. So our denominator flips to 25 over negative 24. You can multiply straight across, or I would recommend simplifying before you multiply. So the 25 on the top and the bottom will cancel. Negative 7 over negative 24 would be positive 7 over 24. Any questions with these three? Let's find our reciprocal functions now. So cosecant would be 1 over y, or we could just flip sine. What do we get when we flip sine? Awesome, negative 25 over 7. It doesn't matter where the negative is. It could be up top, out front, down with the 7, as long as there is a negative there. So you need a negative. Doesn't matter where you put it. What would secant be? Negative 25 over 24, perfect. And then what's cotangent? Perfect, 24 over 7. So you could start from the top and find x over y and do your keep, change, flip, and simplify. Or just flip what you had for tangent. It's going to be the reciprocal of your answer for tangent, so just flip it. All right, let's do 22. So we have negative 7 pi over 6. A negative angle is not on our unit circle. How could we find the equivalent to this on the unit circle? Awesome. We can find a coterminal angle just by adding 2 pi. So we want to find the positive version of it. It ends in the same spot because it's coterminal, but it's just going to be the positive angle. So we need a common denominator. I can multiply the top and the bottom by 6, so 12 pi over 6. Negative 7 pi plus 12 pi would be what? 5 pi over 6. Now let's look at our unit circle for 5 pi over 6. So that would be here. So we're looking at the point negative square root 3 over 2 comma 1/2. So this is our x and our y. And then let's find our 6 trig functions. We have sine of theta, cosine theta, tangent theta. What's the reciprocal of sine? Cosecant theta. Reciprocal of cosine? Secant. And the reciprocal of tangent? Cotangent. So sine tells us we look at what? The y. What's our y value? 1/2. Perfect. Cosine tells us we look at what? The x. So our x would be negative square root 3 over 2. Tangent, we look at what? All right, so y over x for tangent. So we have 1/2 over negative square root 3 over 2. What do we do when we have a fraction and a fraction? Keep, change, flip. Keep the top, change to multiplication. We're going to flip the bottom to negative 2 over square root 3. We have a 2 on the top and the bottom, so we can cancel those out, and we're left with negative 1 over square root 3. Now again, it doesn't matter where the negative is, just don't forget about it. Can we leave a square root in the denominator? No. What do we have to do? Multiply the top and the bottom by square root 3. We got to rationalize. So we get negative square root 3 over 3. So this would be our answer for tangent. Any questions so far? Awesome. Let's find our reciprocal functions. How would I find cosecant? Flip it. It'd be 1 over y. So you do 1 over 1/2 and keep, change, flip. Or just flip the sign. What do we get when we flip sign? 2. Perfect. Same thing with secant. It'd be 1 over x. You could do 1 over negative square root 3 over 2 and keep, change, flip. Or you could just flip cosine. What do we get when we flip cosine?
2 over negative square root 3.
Awesome. So negative 2 over square root 3. But we can't leave our answer like this. What do we need to do? Multiply the top and the bottom by square root 3. We cannot leave a square root in the denominator. So we get negative 2 square root 3 over 3. And then lastly, for cotangent, it would be x over y. So you can start from the top if you want to put your x over y and then simplify, or you could just flip tangent. I would recommend flipping tangent before we've rationalized it. Because if we flip the final answer, we'd have to then rationalize again. But if I flip negative 1 over square root 3, what do we get? Negative square root 3. So practice these. It's not hard math to keep change flip. I know that you guys know how to do it. Just be careful with the math. Be careful with simplifying. Practice these on your own. Let's do 21. So 21, again, we have negative pi. It's not on the unit circle. How would we find the equivalent to this on the unit circle? Add 2 pi. What's negative pi plus 2 pi? Pi. So we're looking for pi on our unit circle. So pi on the unit circle would be here. So the point we're using is negative 1, 0. So let's find our 6 trig functions. Sine, cosine, tangent. What's the reciprocal of sine? Cosecant. The reciprocal of cosine? Secant. And the reciprocal of tangent? Cotangent. So we've got our x and our y. Sine tells us we look at what? The y. What's our y? 0. Cosine tells us we look at x. What's our x? Negative 1. Tangent we look at? Y over x. So 0 over negative 1. What does 0 over negative 1 simplify to? 0. 0's on top. It would be 0. What about for cosecant?
0.
So it'd be 1 over y. So 1 over 0 is what? Undefined. Secant is 1 over x. So 1 over negative 1 would be? Negative 1. And then cotangent is x over y. So negative 1 over 0, which is? Undefined.